Hello students, my name is P. Nagendra Rao, working as a chemistry lecturer in Vignan Cooperative Junior College at Vadlamudi. Today I am going to discuss about the very first chapter in first inter chemistry, that is atomic structure. This atomic structure, the main topics are discovery of fundamental particles of an atom and atomic models like Thomson, Rutherford, Bohr's atomic model. After that, nature of the electromagnetic radiation, Planck's quantum theory of radiation, and how Einstein explained the photoelectric effect property, and what are the differences between emission spectra and absorption spectra. After that, de Broglie's wave nature of the electron and Heisenberg's uncertainty principle, and what is quantum mechanical model of the atom, how this quantum mechanical model of the atom used to determine the quantum numbers values of an electron, and what is Schrodinger's wave equation to determine the shapes of the orbitals, and how Above principle, Pauli's principle, and Hund's rule of maximum multiplicity is useful to write the electronic configuration of the elements in the periodic table. Now, in the chapter, very first topic is fundamental particles of an atom. The atomic theory was proposed by Dalton. According to him, atom is the smallest particle of an element which is unstable. So, it is involved in the chemical reaction either by losing or gaining or mutual sharing of the valency electrons. That means, according to Dalton's atomic theory, atoms are indivisible and invisible also. Are you following or not? According to Dalton's atomic theory, atoms cannot be further divisible. According to Dalton's atomic theory, these atoms are invisible also. But from the studies of J.J. Thomson, Rutherford, Goldstein, and James Chadwick, atoms still containing subatomic particles. The main subatomic particles present in an atom are electron, proton, and neutron. So, these three are the stable particles present in an atom. So, these three particles are known as fundamental particles of an atom. These three particles are present in almost all the atoms except in protium. Protium is nothing but 1H1. Protium containing only one electron, one proton, but the number of neutrons present in protium is equal to 1 minus 1, that is equal to 0. That means protium containing only one proton and one electron only. So, among the three fundamental particles of an atom, the first fundamental particle of an atom is electron. This electron was discovered by J.J. Thomson by using cathode ray discharge tube experiment. That means, in the cathode ray discharge tube contains the cathode and anode, that is made up of a glass tube. Cathode, cation possesses positive charge, cathode having negative charge, and anion is having negative charge, anode is having positive charge, and this cathode and anode are connected to a high voltage battery to provide the high electrical current into this glass tube. This is a discharge tube, but it is made up of glass, and to remove the air present in the glass tube, it is connected to vacuum pump. So, this is the high voltage battery to provide about 10,000 volts electrical current. So, this diagram indicates the setup for the discharge tube experiment which was conducted by J.J. Thomson. So, according to him, when a gas is subjected to electrical discharge at very low pressure about 0.001 mmHg or 0.0001 mm Hg pressure is provided in this glass tube, and if you apply 10,000 volts electrical current into that gas, according to J.J. Thomson, some rays were produced at cathode. These rays move from here, see this one. These rays moves from cathode to anode, indicate these rays consists of negatively charged particles. That's why they attracted towards the anode. That's why according to J.J. Thomson, when a gas is subjected to electrical discharge at very low pressure and high voltage, the cathode rays are produced. According to him, cathode rays consists of negatively charged particles. That's why these rays moves towards the anode while doing the experiment by J.J. Thomson with help of discharge tube experiment. Now these negatively charged electron, that means these cathode rays consists of particles, they possess negative charge. That's why these particles are known as electrons. So the very important point in this experiment is they are having negatively charged particles. In the absence of the field, they move in straight lines, but in the presence of the either electrical field or magnetic field, they shows some deflection. So the magnitude of the deflection depends upon greater the magnitude of the charge on the particle, greater is the deflection. Deflection means interaction between the particles with the field. If the particle mass is very less, interaction between the particles and the applied electrical field or magnetic field is more. Now that particle shows more rate of deflection. So according to J.J. Thomson, greater the magnitude of the charge on the particle shows more rate of deflection. Lighter mass particle shows more rate of deflection. If the strength of the electrical field or magnetic field is more, those particles also shows more rate of deflection. Now this J.J. Thomson's experiment is also seen by using this simple video. In this video is J.J. Thomson, electron charge is negative when a gas is subjected to electrical discharge at very low pressure and high voltage. This is the discharge tube, this is the discharge tube, this is cathode and this is anode, and these two are connected to a high voltage battery to provide about 10,000 volts electrical current, and some rays are produced from cathode to anode. This video represents that one. And see here, in the absence of the field, these particles moves in straight lines. So very important point is cathode rays are invisible, but their propagation can be observed with the help of zinc sulfide screen. That's why in this discharge tube experiment, behind the anode, that discharge tube is coated with zinc sulfide screen. When the cathode ray strikes on zinc sulfide screen, immediately flash of light was observed. So the cathode rays are invisible, but their propagation can be identified with the help of zinc sulfide screen. So this is about the experimental information. Once again, I will repeat the same experiment with the help of this simple video also. Here the pressure is 0.0001 mm Hg pressure, and that means at very low pressure and high voltage, any gas is subjected to electrical discharge, cathode rays were produced. So these are the properties of the cathode rays. In the absence of the electrical field and magnetic field, they move in straight lines. And these rays starts from cathode and moves towards the anode, because cathode rays consists of negatively charged particles. So they are not visible, see here, but certain materials like fluorescent material or the phosphorescence material like zinc sulfide, when the cathode rays strikes with zinc sulfide, immediately scintillations are observed. So with the help of that one, it is possible to see the propagation of the cathode rays. In the presence of the electrical and magnetic field, they shows some rate of deflection from its original path because they are having negatively charged particles. So this is, next one is, this is the original video to observe the specific charge of the electron. So he calculated the charge by mass of the particle value according to J.J. Thomson. Its value is minus 1.76 into 10 power 11 coulomb per gram. So this is the discharge tube experiment, and from this experiment he calculated the specific charge of the electron also. According to him, its value is constant for all gases. That means the specific charge of the electron is uniform for all gases irrespective of the nature of the gas used in discharge tube experiment or metals used as electrodes. If you change the metals which are used as electrodes, if you change the gas, whatever it may be the nature of the gas, the specific charge of the electron is minus 1.76 into 10 power 11 coulomb per kilogram. So he calculated the specific charge of the electron. From gas to gas, its value is uniform. That means the electrons are considered as universal particles of all the atoms. Atoms containing the so many electrons, and each and every electron charge and mass is remains constant. That's why according to J.J. Thomson, the specific charge of the electron is uniform for all gases. If you know the charge of the particle like electron, if it is equal to 1.602 into 10 power minus 19 coulombs, now it is possible to calculate the mass of the electron also. From E by M and E, it is possible to calculate mass of the electron. From this calculation, if you know the E by M value and if you know the charge of the electron, and it is possible to calculate mass of the electron, so the formula is, if you know the E by M value and E, so the ratio between these two gives the mass of the particle like electron. According to him, electron mass is very negligible, which is equal to 9.11 into 10 power minus 31 kilograms, or it is also equal to 9.11 into 10 power minus 28 grams, and it is also equal to 0.0005486 AMU. So that means electron having very negligible mass, and that mass is equal to 1 in 37 the mass of the hydrogen atom. So from E by M and E, it is possible to calculate the mass of the electron according to J.J. Thomson. So up to now, J.J. Thomson determined the fundamental particle like electron by using discharge tube experiment. He calculated the specific charge of the electron also. Very important point, you should remember this point. If you change the nature of the gas in discharge tube, the specific charge of the electron is uniform for all gases. Its value is minus 1.76 into 10 power 11 coulomb per kilogram. If the charge of the electron is expressed in coulombs, now E by M value of the electron is minus 1.76 into 10 coulomb per kilogram. If you know the charge of the particle like electron in coulombs, it is possible to calculate its mass also. And the next one is charge of the electron. There is a lot of difference in between specific charge and charge. The specific charge means it is the ratio between charge of the particle and mass of the particle. Formula is E by M. And now the Millikan oil drop method experiment is used to determine the charge of the electron. So he is the photograph of Millikan. This is Millikan's oil drop method experiment. This is a chamber. In the chamber there is air. X-rays are made to struck with air. Charged particles are formed, and from the top of the chamber oil droplets are dropped into the chamber, and those oil droplets, these are the oil droplets, they absorbs the negatively charged electrons. The negatively charged electrons are produced when the X-rays bombardment with the air present in the chamber in the presence of gravitational force, liquids having viscous force also, and these are the droplets of the oil, and this is the reaction between X-rays and air. From that reaction negatively charged particles are produced. These particles are absorbed by oil droplets, and from that he calculated the charge of the electron by Millikan. So according to Millikan, charge of the electron in coulombs is minus 1.602 into 10 power minus coulombs. According to Millikan, the charge of the electron, the magnitude of the charge of the charged oil droplets is equal to integral multiple of the electrical charge. That means Q is equal to N into E. According to Millikan's oil drop method experiment, the charge of the electron in SI system is equal to minus 1.602 into 10 power minus 19 coulombs in SI system or in MKS system. According to Millikan, the charge of the electron in CGS system is 4.8 into 10 power minus 10 ESU. So here the charge of the electron is expressed in MKS system, that means SI unit. Now from E by M ratio and E, it is possible to calculate the mass of the particle like electron. Now the second fundamental particle present in an atom is proton. 1H1 representation is. In the similar way, electron representation is E minus 1 charge, 0 mass. 0 mass means nothing mass. Nothing mass means mass is very negligible. It is already known to you. Its value is 1 by 1837th the mass of the hydrogen atom. That means mass of the proton. When compared with the proton's mass, mass of the electron is very less, which is equal to 1 by 1837th part of the mass of the hydrogen atom in the case of electron. That means proton mass is 1837 times more than the mass of the electron. So now the second fundamental particle is proton. The name proton was suggested by Rutherford, and it was discovered by Goldstein by using perforated cathode in discharge tube experiment. In the same experiment, cathode is having holes. That's why when hydrogen gas is subjected to electrical discharge at very low pressure and high voltage, positive rays were produced. That means those rays moves from anode to cathode, opposite, anode to cathode. That's why the positive rays are also named as anode rays. Here cathode is having some holes, pores. Through the holes, anode rays are passed through that cathode, and they struck with the zinc sulfide screen. Immediately scintillations are observed. That's why the positive rays are also named as anode rays or the canal rays. Very important point is Goldstein discovered the fundamental particle electron by using hydrogen gas in discharge tube, because hydrogen gas consists of hydrogen molecules. When the hydrogen gas is subjected to electrical discharge, the molecules present in the hydrogen gas absorbs the energy and they splits into hydrogen atoms. At the same time, hydrogen atoms are converted into hydrogen ions. Each H plus ion contains only one proton. One proton mass is very less. So, in the formula of E by m, if the particle mass is very less, E by m value is more. That is why only for hydrogen gas, the specific charge of the proton is maximum. Remember that, my dear students. That means the specific charge of the proton varies from gas to gas. Remember that. But in the case of electron, its specific charge is uniform for all gases. That means electrons are considered as universal particles of all the atoms, but not in the case of protons. From gas to gas, the specific charge of the positive rays varies. That is why he used only hydrogen gas containing H plus ions. It is the lighter mass. That is why at the same time H plus ion contain only one proton. So, its mass is very less when compared to He plus ion containing two protons. When compared with one proton mass, two proton mass is more. That is why the specific charge of the helium ion is less. So, he used only hydrogen gas to discover the fundamental particle proton. According to him, the specific charge of the proton is 9.58 into 10 power 7 coulomb per kilogram. That means when compared to electron, the proton specific charge value is less. Video how the canal rays or positive rays or anode rays are produced according to Goldstein. This is the photograph of Goldstein. Now this is anode. Anion is having negative charge, anode is having positive charge. Now this is perforated cathode, pores, there are holes in this cathode. Now this is hydrogen gas. Hydrogen gas contains hydrogen molecules. When hydrogen gas is subjected to electrical discharge, hydrogen molecules splits into hydrogen atoms. Now the hydrogen atoms are converted into H plus ions. Now this is a positive ion passed through the canal, holes, pores. That is why these rays are known as canal rays. See here, positive ions are passed through this perforated cathode. See here clearly. This video clearly indicates cathode is having pores and positively charged particles are travels through this pores. If they strike with the zinc sulfide screen, they shows some rate of deflection, and this was designed by Wien. This apparatus was designed by Wien. See here, in the absence of the field, they directly struck with the glass tube, but in the presence of the electrical field, they shows some rate of deflection because positive rays are, see here, deflection. Like cathode rays, anode rays also shows some rate of deflection because positive rays consists of the positively charged particles. So this is about the discovery of the fundamental particle like proton. So the main difference between these two is from gas to gas, the specific charge of the proton varies. From gas to gas, the specific charge of the electron remains constant. Remember that. So in the case of electron, the specific charge is minus 1.76 into 10 power 11 coulomb per kilogram. In the case of proton, the specific charge is 9.58 into 10 power 7 coulomb per kilogram. So generally, in the first topic, you should remember the charge, mass and E by m values of the each fundamental particle in this first topic. So in IIT JEE Main also they will ask this type of values also. Now the third fundamental particle present in an atom is neutron. It is neutrally charged particle. That's why its discovery becomes too late, and the existence of the neutrally charged particle was predicted by J.J. Thomson, but it was discovered by James Chadwick by bombardment with alpha particles. Alpha particle is nothing but helium particle. Helium atomic number is 2, mass number is 4. 2He4 is known as alpha particle. When an alpha particle is hitting with beryllium and neutrally charged neutron was emitted. See this video also. This is very nice video. See here, all of you see here, and this is the photograph of James Chadwick. He discovered the third fundamental particle, neutron. This discovery becomes too difficult because neutron is neutrally charged particle. So according to him, see here, according to him, alpha particles, these are alpha particles, 2He4, bombardment with beryllium. Beryllium atomic number is 4, mass number is 9. When 2He4 bombardment with the 4Be9, immediately 0N1, that means neutron particle was emitted. At the same time, beryllium nuclide is converted into carbon nuclide, 6C. So note down that reaction also. 2He4 plus 4Be9 gives rise to 0N1, small n indicates neutron representation, plus 6C12. So this is about the discovery of the fundamental particle neutron. So very important point is neutron is neutrally charged particle. That's why the specific charge of the neutron is 0. But its mass is slightly more than the proton mass, and its value is 1.675 into 10 power minus 24 grams. So this PPT, this slide indicate the symbolic representation of the electron, the symbolic representation of the proton. This is represented by negative charge because this is uni-negatively charged particle. Proton is uni-positively charged particle. Neutron is 0 charge. That's why its charge is 0. In atomic mass unit, one of the unit of atomic weight is AMU, atomic mass unit. Another representation is Avogram, nothing but AMU is nothing but Avogram. Avogram is nothing but unified mass. One AMU is equal to 1.66 into 10 power minus 24 grams. So it is possible to calculate grams into AMU also. So see this table. This is very important table while doing the problems in IIT JEE main examinations. For the electron, the mass in AMU is this much, 0.00054886 AMU. Its mass in grams is 9.10 power minus 28 grams, and simple representation of the charge is -1 in the form of unit. In terms of coulombs, its value is -1.602 into 10 power minus 19 coulombs. In the similar way, proton mass in AMU is 1.00759. In grams, its value is 1.672 into 10 power minus 24 grams. In the form of a number, it is represented by +1. That's why proton is derived from protium. So its symbolic representation is 1H1, and the proton charge in coulombs is just opposite. This is negatively charged and this is positive charge. That's why its value is 1.602 into 10 power minus 19 coulombs. And very important point is the neutron is neutrally charged particle. That's why G is 0, and the E by m value is also 0. So 0 by anything is equal to 0. Similarly, and another important point is the neutron mass is slightly more than the proton mass. See here, 1.00759, this is 1.00866, or in the form of grams, 1.672 into 10 power minus 24 grams, and in the case of nitrogen, its value is 1.675 into 10 power minus 24 grams. This is the representation of the helium. 2He4 alpha particle is nothing but 2He4 due to interaction between protons and neutrons present in the nucleus. So many other unstable particles are also formed in the nucleus. One of those is photon. Photon representation is gamma. Its charge is 0, mass is also 0, and this is already known to you. And another particle present in the nucleus is positron, E plus, electron, E minus, or beta particle is also another representation of the electron, E plus, positron, so positive charge, so antiparticle of the matter అని పిలుస్తారు. Now the final conclusion about three fundamental particles of an atom is like this. See here, according to, it is already known to you in the lower classes, according to Rutherford's alpha particle scattering experiment, each and every atom has a nucleus. Its charge is positive, it containing, that nucleus containing protons and neutrons. That means according to Rutherford alpha particle scattering experiment, almost all mass of the atom and positive charge is concentrated at center part of the atom, which he called the nucleus. So among the three fundamental particles of the atom, massless particles are proton and neutron. When compared with proton, neutron mass is slightly more. That's why according to Rutherford's alpha particle scattering experiment, the electrons revolving around the nucleus just as planets do around the sun. That means according to Rutherford's alpha particles experiment, among these three fundamental particles of an atom, the proton and neutron present in the nucleus and the negatively charged particle like electron present outside the nucleus, it revolves around the nucleus. So this is position of the three fundamental particles present in an atom. So very brief summary about the first topic in the chapter is Dalton's atomic theory is not correct. According to Dalton's atomic theory, atoms are indivisible and invisible also. Atoms are invisible, that is correct, but atoms still containing subatomic particles. About 36 other particles are also present in an atom, but most of them are unstable. Only the stable particles present in an atom are electron, proton and neutron. Among these three fundamental particles, electron possess uni-negative charge, proton possess positive charge, neutron charge is 0. And finally, very important point in the case of IIT JEE main exams is the specific charge of the electron is uniform for all gases. Its value is minus 1.76 into 10 power 11 coulomb per kilogram. But in the case of proton, its specific charge of the proton depends upon nature of the gas used in discharge tube experiment. For hydrogen gas only, specific charge of the proton is maximum because H plus ions are produced only from the hydrogen gas. Please remember that. And in the case of neutron, the specific charge of the neutron is 0 because it is a neutrally charged particle. So this is